All right, we are going to look now into 2.3, which is something titled piecewise functions. And what that means is we're going to have different functions represented in single questions. And to illustrate that is a question about postal rates. And when you go to mail something, how much you pay depends on size, but it also depends on mass. So in this case, you can see that the value you're going to pay will be $1 if your mass is between 0 and 100 grams, and $1.70 if it's between 100 and 200, including 200. And the last option for us is if it's between 200 and 500. So when you look at those, you can anticipate that the cost of mailing something that's 163 would be the second interval, so that would cost you $1.70. 48 grams would be $1 because it's between 0 and 100, and 480 would be $2.45. And we can represent this graphically, which is a big chunk of this lesson. That this graph has 3 pieces to it. It is 3 separate lines, and you can see that we have an open circle where the interval was open, or the round bracket, and closed dot for the closed intervals. Now we're not going to look mostly at concrete examples. We're going to look at abstract examples such as the one you are currently looking at. We have the graph equaling -1 from -infinity to -3. So I'm going to go ahead and highlight that right now, from -infinity to -3. And then between -3 and 1, we're going to have another graph, so between -3 and 1. And then lastly, we have from 1 to infinity, a different graph in which you're going to develop skills in, and saying, oh, well, that's a constant function. I know what that looks like. And then you're going to say, oh, that's a linear function. I know what that looks like. And lastly, we have a quadratic, and we know what a quadratic looks like. And we're going to draw these graphs over these intervals. So let's start with the easiest one, which is the constant function. This graph is -1 until we reach -3. So at -1, I would draw a straight line until I reach -3, and this goes on to infinity forever, and it does not include -3, so I'm going to have an open circle there, indicating that once we get there, that we don't have the line anymore. It turns into, at -3, a linear line, or a linear function, which has a slope of 2 and a y-intercept of 4. So I'm going to go ahead and put the y-intercept at 4. And if the slope's 2, I would go up 2 and over 1. There's another option, though, and that is just using a starting and end point, where we know this graph starts at -3. If I replace x with -3, 2 times -3 is -6. -6 plus 4 is -2. So this graph would start at -2. And it would be a closed dot because at -3 it's a square bracket. And at the right-hand side of this interval is 1, not including 1, but we could still replace x with 1. 2 times 1 is 2, plus 4 is 6, so I can go to 6. And whoops, I made a mistake there. That should be an open circle because it's a round bracket there. And then I would connect with the straight line, and you'll notice it goes through our y-intercept of 4, which is no surprise. Now the last function is quadratic, and you might recognize that this is of the form ax minus h squared plus k, and so we know that our vertex is at h comma k, in this case 1 and 7. But if we didn't know that, we could still kind of do just the table of values idea and just start drawing the parabola. For instance, if I put 1 into that, 1 minus 1 is 0, 0 squared is 0, plus 7 is still 7, so at the value of 1, it's going to be equaling at 7, and that's a square bracket, so it would include that. Now, what if I put 2 in? Well, 2 minus 1 is 1, 1 squared is 1, negative in front, -1 plus 7 is 6, so I would be here. If I put 3 in, 2 squared is 4, minus 4 is 7, minus 4 is 3. What if I put 4 in? Well, that would now be -9. I'm going to be at -2. What if I put 5 in? 5 minus 1 is 4. 4 squared is 16, minus 16, a -9. What if I put 6 in? 6 minus 1 is 5. 5 squared is 25. And we would continue to get the shape, and you can see it opens down. That this is the vertex right here at 1 and 7. There's your vertex. And the parabola continues to open down. And we don't get the whole parabola. You wouldn't want to draw this on your assignment, but we know the whole parabola will look something like this. But the piece of the parabola that we see, and that's why it's called a piecewise function, is simply the portion from 1 to infinity. And that is basically your assignment, and you're going to run into the opposite, which is, okay, if I have this, well, I have a linear function. How do I create the equation of a linear? Well, the constant function, that's easy. That's just y equals 4. And then again, we have another parabola, it looks like. How do I come up with the equation of a parabola? And you're going to have to review those things when you do your assignment. And that's it. So get some practice at that next time we're in class and ask me questions, and I'll be glad to help you, and I'll see you then.